So we're going to continue with chapter 5 today, complex fractions, and then we go into 5.5, solving equations. Now, if you are listening to me, that's more for you people who are not here, not attending on a regular basis. You guys, you need to be in class. We only have 4 more weeks. So what I said earlier, we are in the last 5 miles of our marathon. By the way, I'm running, I know I haven't shared anything yet because I forgot if I want to open Doceri first or not. So right now I'm not sharing anything other than myself. If you could see me. Oh, let me share the screen. I may have to open Doceri back. I haven't even opened it. Okay, so where was I going with this? Oh, I'm running a 4-mile Easter run this weekend on Saturday. So we're in the last 5 miles of our marathon. We got 4 more weeks left. And for you people who are here, like I said before, I'm preaching to the choir. You do what you're supposed to for the most part. Attending is a big part of your overall grade. I am telling you, if you're not attending, most of the times you're not even going to listen to the videos that I'm recording, and I will post the one from Monday. So I'm saying to the people who are not here. So I'm hoping somebody listens to me and comes to class. I will send out an email. There are things that need to be done, and if you only look on Falcon Online once a week, then you're missing out on important deadlines. Quizzes are open. They are open for a week. There is no reason not to do a quiz. You have a whole week to complete them. You have 2 attempts. By the way, I think 5.1 is closing this evening, so the due date is today. Then we have 5.2, 5.3 quizzes that are open, and I'm the last one. I'm going to say one more time, that does not want you to get out of this class, go on to the next math course. And if I'm giving you the opportunity to get extra points on your test, and I see only 7 people turned in test corrections, then, you know, that's, I want you to get more points. So, but that's up to you. I can only say it. I can only offer it. What you make out of it, that's up to you. You can email me, you can talk to me, you know, if you have any concerns, anything, but I really want you to succeed and also to come to class because I miss you. Oh, that's for the people who are not here. Okay, what else? Let's get going then. Let's see what Doceri is doing today. Oh, one more thing, Friday, and I will let you know Friday morning, but I'm going to a day-long conference, and this will be the last one. But I'm planning, because when they have lunch, it's between 11 and 12, so I will be online, and this will work. This is not in a hotel. This is at a college, a little bit further south. So I will be at a college. There's Wi-Fi, there's everything here. So plan for 11:15, just to give me some time to make sure, because I'm doing a presentation, not on Friends, but on technology. Gotta make sure it works. So, but I will email you Friday morning, but I will be online, at least that's I'm planning now, with class, with review questions. We are on schedule, so I'm not worried about that. But Friday at 11:15. Okay, so I will email you a little bit more details. Just be on Teams. Okay, let's see what Doceri is doing and see what we can do here. Everybody in now who wants to be here? Okay. Oh, I'm giving a talk on technology trends, so let's hope it's all working. What are we doing? 5.4, right? Okay, here we are. So let's do a few things before we get to complex fractions. I want to review a little bit because next week at some point we have a test. I have to look at the schedule, maybe on Wednesday. I haven't figured it out yet. So f of 5, you have a function here, rational function, which is x plus 2 over x minus 7. What is f of 5? Fraction on fraction. Yes, fractions are our friends, Elijah. You got that right. The more fractions and factor. So Mark says the answer is -7/2. I don't know, I haven't done it yet. So we replace our x with 5 plus 2 over 5 minus 7. Do the arithmetic, 7 over -2. You are absolutely correct. Thank you. Moving on to the domain. What is the domain? How do we find the domain? We have to set what equal to 0? Denominator. So the RV, the restricted value, x minus 7 is 0, x is equal to 7. How do we write that in domain? We have an, Rodney, I like the infinity symbol. That's really cool. We have infinity to 7, you wrote -7. There's two parts. If I show you on the number line, we have a 7 here, so we're coming from the left, and we're going to the right, and we're jumping over the 7. So the domain would be, in this case, -infinity to 7, parentheses, because 7 is not included, it's excluded, union, I know, Mark, 7 to infinity. That would be the domain. Okay? Yes, yes, but you get a credit for the infinity symbol. Pretty cool. Okay, next. I'm giving you a domain. Like in this case, it's -infinity to -3 and -3 to infinity. And you give me an example of a function, of a rational function that has the given domain. Anybody? Tony Ann. 1 over x plus 3 is indeed a very fine example of the given domain. You got to make sure that your denominator has the opposite to whatever is given. It's always opposite. And whatever you put on the numerator is really up to you. So the easiest one would be 1 over x plus 3. What you cannot do is write 0 over x plus 3 because that would be 0. Okay, next. Simplify. These are all problems you have to do again on a test. And when I say simplify with the rational expression, that really means one thing first, and that's factoring. You have to factor first. And both of these trinomials have a leading coefficient 1, so we could go ahead and make our two parentheses. We have no GCF, that means K is in each binomial. And for the first one, we're looking for two numbers that multiply to -10 and add to 3. And Danielle says +5 and Elijah -2. Right. And for the denominator, we're looking for 2 a combination of numbers that gives us 6 and -5. 2 and 3, and they both have to be negative. Yes, Danielle. So -2, -3. Which order you're right now, Rodney, you are correct, is totally up to you. Now we have the same factors in the numerator and denominator, and we're allowed to reduce them. And please, I said it last night, not to you guys, but to other students, you want to write the 1 down, because we had an answer that was 1 over x plus 5 or something, and everybody said x plus 5. So when you're reducing, it actually reduces to 1. It doesn't go away like we always say, we cancel it. Just cross it out. Okay, and what is left is our answer, which is k plus 5 in the numerator over k minus 3 in the denominator. Done you are. Moving on to the next problem, you will. Any questions? So these are some review questions of what we have done so far, and I think I have another one. I don't want to do this right now. Maybe if we have time later on. This is just all factoring and then reducing what we can. I don't want to do this either. That one I want to do. A plus 2 over 2a plus 6 minus 3 over a plus 3. This is a subtraction problem of different denominators. What do we have to do first? Anybody?
We have to find the LCD.
We have to find the LCD. That is correct. Yes, Mark. And finding the LCD means, first of all, that we must factor denominators if they can be factored. 2a plus 6 can be factored. How? Okay, I'm going to tell you. The GCF is 2, and you have a plus 3. Allergies are really bad this week. I don't know. Doctor told me to take something finally. Okay, now we're comparing our denominators. I may have to go and get a drink. We're comparing our denominators, and they both have an a plus 3, so we're good there, but the right-hand side is missing what? A 2. So we're going to multiply numerator and denominator by 2. So our least common denominator is 2 times a plus 3. And in the numerator, we have an a plus 2 minus 6. Combine your like terms. 2 minus 6 is a minus 4 over 2 times a plus 3. So now my question to you is, can I do anything more, or am I done? That is really the big difficulty. You guys do homework and you think, am I done yet, or can I do more? What? When? How? Can I do more here, or am I done and move on to the next problem? We should have a little poll. Who thinks we can do more? More? Can I do more? Anybody? Elijah says no. Mark says done. Valentina says, can you reduce the -4 and the 2? Thank you for saying that. I was waiting for somebody to go there. And the answer is no. No, no, no. This is a subtraction problem. It's really not, it is a minus 4. So be careful. A minus 4, if this would have been a times 4 over 2 times whatever, then we could have said yes. But since there's a minus, we have to say no, and we have to say this is it. There is no more, ooh, I like this color, no more you can do. You're done. So be careful. You cannot reduce within addition and subtraction. And I don't want to do this one. No. Okay, let's go back to complex fractions. Now, complex fraction is really nothing else than a fraction over a fraction. And a fraction over the fraction is a division problem. So we talked about this on Monday. This would be, it wasn't the same problem, but this would be 1/2 divided by 3/4, which then changes into 1/2 times, because division of fraction is multiplication of the reciprocal. And why don't I write the reciprocal? We will never know. 4/3. Here you go. And then we have to see if we can factor or reduce further. The 2 goes into 2 once and into the 4 twice. And the answer is 2/3 in this case. So we did a couple problems, and I don't want to redo them again. I think we did this one. Now we're at the point where we're going to, actually, let's go back and review this one here. We have x minus 6 over 3x. I'm pretty sure we did this problem. We can do it again. Now divided by 3x minus 18 over 9. So this becomes times what? 9 over 3x minus 18. And then we go ahead, just like we did in 5.2, we see what we can factor. The 3x minus 18 can be factored into 3 times x minus 6. And then we reduce. X minus 6 over x minus 6 reduces to 1. In the denominator, I have a 3 times 3, which is a 9. So these 3 reduce with that 9, and that's also a 1. What is the answer here? What do we have left? Be organized. What do we have left?
What did you do to cancel out the 3 next to the x minus 6?
The 3 goes into 9 3 times.
Okay.
And then I crossed out this 3 over here. That goes into 3 1 time. So, okay, where were we? What do we have left? In the numerator, there is a 1 over x. Yes, guys, online, you got it. Yes, that's it.
Why would it be just x? You didn't reduce the 3x. Oh wait, yeah, you did. Never mind.
This one I factored. Yeah, once it's factored, we don't need it anymore. Yep. Okay, now let's do a problem.
You ever had like real mayo?
Y minus 1 over y
Minus all the time. I just want to
1 minus
No.
1 over y squared.
Like real, like fresh mayo.
So here we have work to do.
Yeah,
And
I
we're
always
basically
think
doing the
store.
same
Mayo
work
is made
here
with,
as we did in 5.3.
mustard and
We're adding the numerator separately from the denominator. So we have to do, in this case, subtraction. We have
So
to
the
do
ones from
2
the stores,
subtraction with different denominators separately.
So you,
So
you made this yourself?
where we work in the numerator first, Now pay attention when you just have a y. This y is actually over 1. And this 1
I was gonna knock on your door the last time.
So make sure you have fractions, numerator and denominator there.
My door is shut. I just say don't talk to me if my door is shut.
Okay, somebody has their microphone. Elijah, I can't hear him, so Elijah, can you please mute yourself? It looks like Elijah is okay. You can hear me now? We have technical. Mayo and mustard, what? Okay, can you hear me? Everybody. Okay, cool. Moving on again. Yes, everybody mute themselves, please. Okay. Okay, cool. Now, moving on. So strictly look at the numerator. And we're going to go about the way we did the same as we did in 5.3. What is missing? Compare your denominators. In the numerator, we have y over 1 minus 1 over y. What is missing? The left-hand side is missing what? A y. So we're going to multiply by y over y. It's missing a y. So that leaves us with y squared minus 1 over y in the numerator. Now let me write the denominator, 1 over 1 minus 1 over y squared. Now if you look strictly at the denominator, what's missing on the left-hand side? Y squared over y squared. We have to multiply numerator and denominator by y squared, which is now y squared minus 1 over y squared. So you are combining the numerator first, and when I say numerator, I mean the top of the complex fraction. We perform our subtraction by finding the least common denominator and go from there. And then we look at the denominator of the complex fraction. We're gonna subtract here, find least common denominator. And now I can rewrite the problem. So now you have y squared minus 1 over y times, we're changing it into the reciprocal, y squared over y squared minus 1. And then you see what we can factor, or actually don't really have to factor here, because we have the y squared minus 1 over the y squared minus 1, that reduces to 1. So we can reduce this right away. Then we have y squared over y, so 1y goes into a y here, and we only have y to the first power left. So the answer to this whole problem is y. Guys, any questions here? So we work separate, and that's something you're going to have to practice. You work separate from the numerator and the denominator to combine, find your least common denominator, combine like terms, just like we did in 5.3, and then you flip it. And that takes some getting used to. This is not an easy process. Let's do another one. 5 over b plus 4 over b plus 1 divided by 4 over b plus 1. There's a minus here. Minus 5 over b plus 1. So we're strictly going to work in the numerator. What is the 5 missing? Well, Write it down first. Let's give you a minute. So does anybody know what the 5 is missing on the left-hand side?
+1.
No? If you just multiply it by 1, then you're not really changing your denominator. You cannot just say +1 + 1. That's not allowed. But that's a good point that you make because a lot of students do that. The b plus 1 is one factor, and the b is another factor. They have really nothing to do with each other. So Mark is correct by saying the 5 needs to be multiplied by b plus 1, both sides. And the 4 is missing what? What is missing that one side has but the other one doesn't? A b. Now we have the same denominator, which is b times b plus 1. Be careful. Don't just say, oh, let me add a 1 here to it. That's really not what this is all about. And in the numerator, we have a 5b plus 5. I'm going to distribute the 5 plus 4b. I'm going to leave it like this for now. Luckily for us in the denominator, we already have the LCD. So we don't really have to find anything that's missing. We're just working in the numerator. 4 minus 5 is a -1 over b plus 1. Is everybody with me? Now the third step would be, well, let me combine like terms here first. 4b plus 5b is 9b plus 5 over b times b plus 1 times, do I have enough room, multiply by reciprocal of denominator. And simplify. And simplifying means that you factor and all this good stuff. So the reciprocal of the denominator would be b plus 1 over -1. You can clearly see that the only factor we have in common is the b plus 1. We reduce that to 1, and the final answer would be 9b plus 5 over -b. b times -1, -b. How do you like that? It takes some getting used to. Let's do another one. Ooh, how about this one? This has been on a test before. It's in the book. This is numbered somewhere in the book. Oh, it's not in the book. Maybe it was on the test. No, it is in the book. It's number 34 on page 411. Okay, now, first of all, this 3 is over 1 and this 3 is over 1. So put them over 1 so you know what's missing. The 3 in the numerator, what is it missing? We're strictly looking at this sum.
P minus 1?
Yes, we need to multiply numerator and denominator by p minus 1. So p minus 1 is your LCD. And in the numerator, if I am distributing the 3, you get 3p minus 3 plus 3, which can be simplified into 3p over p minus 1. Is everybody with me? Speak up. I'm going to let you do one by yourself in a minute. Now the denominator here, we are missing what? Just a p, right? So you get 3p, let me write it over here, minus 3 over 3. This is where we are. Well, let me write it here too. And now we're at the point where we can do flipping. You can only do flipping if you don't need LCDs anymore. Tony Ann, you had a question?
I understand maybe about the 3p minus 3, but how do you get 3 in the denominator?
That is a good point. Thank you. What did the instructor do wrong? There should be a P, right? Because that's, yeah. I had 3's on my mind. Three P minus 3 over P. Okay, now we're going to flip 3P over P minus 1 times P over 3P minus 3. This is what we got. Now, in order for us to see if we can simplify, we must factor what we can. What can we factor here? The
3p minus 3?
The 3p minus 3 is the only, yes, Danielle, Mark, you are correct. The only expression we can factor is the 3p minus 3. We factor out a 3, which gives me a p minus 1. So this is done. Cross it out or erase it. We don't need any more. We factored it. And with this problem, again, this problem had been on a test. There's only one number that I can reduce. What am I allowed to reduce here? The 3's I'm allowed to reduce and nothing else. This 3 with that 3. That's the only thing I can reduce. So in the numerator, you have p times p, which is p squared left. And in the denominator, you have p minus 1 times p minus 1, which is p minus 1 squared. And that is your answer. How do you like that? Why can't you reduce both the p minus 1 and the 3? Well, I have no other p minus 1 that both p minus 1 may not look like that, but both p minus 1s are in the denominator. I'm not allowed to reduce next to each other. It can only be up or down or diagonally. Yeah, see that sometimes the way the handwriting or the way it's listed, you got to be careful. This p minus 1 and that p minus 1, they're both in the denominator. Okay, let's do one more. How about this one? That is number 29. Now, with the numerator, they are not separated here with any plus or minus. Guess what? There's nothing we can do in the numerator. We're going to keep it and only strictly work in the denominator. The top I cannot simplify because they're not separated. It doesn't look like, bless you. If there would have been a plus between the terms, the expressions, then I needed to combine, find the LCD and so forth. But we don't have that. I just want to point that out. But we have it in the denominator. So the y on the right-hand side is missing what? What? We have a 1 here. So we need to have the same denominator.
1 plus.
That is correct. Y plus 3 over y plus 3. There you go. So your denominator is y plus 3, and in the numerator you have the first y plus, now you got to distribute this y, which is y squared plus 3y. Let's flip it, y over y plus 3 times y plus 3 over, let me write it in descending order, y squared plus 4y. You do the rest. You tell me what is the answer. If you have an answer, type it. Gabriel, I see you typing. I did email you back this morning. So May 9th is the correct day. Danielle says 1 over y plus 4. Is she correct?
1 over 5y.
Okay. Danielle has 1 over y plus 4, and Chloe has 1 over what? 5y. Okay, let's find out which one is the correct one. Well, first of all, and Chloe, you probably can see in a minute what you may have not done correctly. The y squared plus 4y, did you combine them into 5y?
No, I did, I factored the, I forgot to factor the y.
Yeah. We need to factor out a y, and that leaves you with a y plus 4. Yes, you got to factor out a y. A y is your greatest common factor. And then we can reduce the y plus 3 with the y plus 3, that reduces to 1. And this y with that 1y here, And then what we have left is Danielle said it 1 over y plus 4. Yep. Yep. That's it. Okay. Let's see if we have one more and then we're gonna go the rest into, oh, we did this one already, I'm pretty sure. Hold on, let's erase that one. Let me find a good one in the book. You want a real good one? Or, okay, let's try 35. That may be a homework problem anyway. 35, 2 over a minus 3 over a. Did we do this already? Looks familiar. No, now we're gonna do it. Actually, no, sorry, changed my mind. Let's do 37. 1 over y plus 2 plus 4 over y minus 3 all over, oh, this is a good one, 2 over y minus 3 minus 7 over y plus 2. I'm going to give you a minute or two, or 3. No, not 3 minutes. Go for it. If you can do that, you can do them all. Work in the numerator first. There is, however, a problem. I wanted to show you. Why am I dirty? Oh yeah, I'm gonna do this other problem real quick. Gonna help you with the top. On the left-hand side, we gotta multiply by y minus 3. And the other side needs to be multiplied by y plus 2. That is your LCD. Y minus 3 times y plus 2. And then in the numerator is y minus 3 plus 4y plus 8. Okay, we're going to combine that in a second. Go ahead and work in the denominator. If you have an answer, let me know. I'm going to help you some more now. We're going to multiply by y plus 2, y minus 3, y minus 3. So denominator y plus 2, y minus 3. In the numerator, I have to distribute the 2y plus 4 minus 7y plus u plus 21. Do you have that? Yes, good. And if we combine like terms, you can see that the denominators in the numerator and in the denominator are the same. So we can just, right away, they reduce to 1. Cross them out. Put a 1 there. What you have left is, combine like terms, y plus is 5y plus 5 in the numerator over 5y plus 25. That is what we have left. And don't even think about it. Oh, 5y, I'm going to cancel those out, and the answer is 1/5. That is not the answer. I see you guys typing, so I'm just waiting for you to give me an answer. We have to factor the numerator. You can divide everything by 5, or we factor the numerator into y plus 1, or 5 times y plus 1, and the denominator into 5 times y plus 5. And then we go ahead and, is the denominator negative 5y? No. The 5's reduce, and the answer is y plus 1 over y plus 5. That is your answer. Gabriel, what negative 5y are you talking about? 2y minus 7. Oh, you are correct. 2y minus 7y is, hold on. Let's see where that, it would be right down here. 2y minus 7 is a negative 5y. So if we are reducing, okay, let me do this again. We're factoring out a negative 5, and that gives you a y minus 5. So this is a negative 1 still down there. So the answer, if you want to put your negative, would be like that. Y plus 1 in the numerator over negative 1 times y plus 5. Thank you. You can write it as negative y minus 5, but you don't have to. It looked better when we didn't have the negative 1, but that's all right. Okay, actually, I saw one more because I've seen that on test as well, and there's always a lot of reducing mistakes. 2 over y squared plus 1 over y all over 4 over y squared minus 1 over y, and that is number 24. This problem I've seen on test before. If we're working in the numerator, we see that the right-hand side is missing a y. 2 plus y over y squared. And the right-hand side is again missing a y, and that would be 4 minus y over y squared. Now, if I write it out, just to show you that the y squareds reduce. So the y's reduce to 1, and the answer is 2 plus y over 4 minus y. And a lot of students give me an answer of 1/2, and then I get mad. 1/2 is incorrect. That is your answer. There is nothing more you can do to it. I do a similar problem each semester and everybody's always laughing. Oh yeah, I will not do that. I will not do that. And then I look at your test, 1/2. Do not do that. There's a plus and a minus in between. Just want to point that out. Watch the video again. You heard it from me first. There you go. We have a couple minutes. We will now talk about rational equations. Rational equations are equations with one or more rational expressions. Now in the book, it doesn't say what it has to have, so I wrote it there. It has to have an equal symbol. If it's not equal to anything, then it is not an equation. Like, for example, 1 over x plus 5 plus 3x plus 9 over x equals 29 over x minus 6. I just so made that up. That would be a rational equation. And guess what? The way we solve it is a little bit different than the book. The book says just multiply everything by the LCD. We do the same thing we have been doing throughout the entire chapter. We're going to multiply by whatever is missing. That's the easiest way to do these. We're going to multiply by whatever is missing, which is kind of multiplying by the LCD. So let me give you an example. If I have one here coming, no, I'm going to write one down. How about this one? 3/5 plus 1 over x equals 2/3. Okay, so we're going to look at this as it was an addition problem. We're going to multiply by what is missing. In other words, we are doing it in just not so many words. We will clear the fraction. It will come in a second. So we have a 5 in the denominator. What's missing there?
X.
An x for sure. And what else is missing? And a 3. We got to make them the same denominators. So we're missing a 3 and an x. The 1 over x, what is it missing? A 5 and a 3, or in other words 15, and the 3 is missing an x and a 5, an x and a 5. So if you do that just like we've been doing it through the entire chapter, that makes it easier for you. At least I'm hoping. So far it has never been a problem for other students. Now, because we did that, guess what? We're going to cross out the denominator. We don't need it anymore. So basically, we multiplied everything by 15x, and then we reduced, and that's whatever we have left in the numerator is the equation that we need to solve. So in the numerator now, 3 times 3 is 9x plus 15 equals 10x. So much easier. Because really, what we did is we multiplied everything by 15x, so the 5 goes into 15 3 times, and we still have a 3x here. Same process, just, I think, easier way. Now to solve the equation, we are subtracting the 9x. Guess what? Done you are. X is equal to 15. Life is good. Next problem. So in other words, we're going to multiply everything by the missing pieces and then just cross out the denominator because we don't need it anymore. And we are going to only work in the numerator. Now there's one more bit of piece that you need to remember, and we're going to do this kind of problem right now. 5 minus 8 over x plus 2 equals 4x over x plus 2. Now I did this on purpose. Look how large I wrote this 5. I don't like it. The 5 is actually over 1. So make it a 5 over 1 so we have numerators and denominators. This seems to be hopefully kind of an easy problem because the denominators are the same, so there's only, the 5 is only missing something. What is the 5 missing? People, are you with me? Danielle? Yes, I know you're there. X plus 2, right, so we're gonna. Now when I learned this, I only looked at the numerator, what's missing, and that's the only thing I really wrote down. So the 5 is so we have the same denominator, cross it out, we don't need it anymore. We're working in the numerator, you get a 5x plus 10, don't forget to distribute, a minus 8 equals 4x. And this is a linear equation, you all know how to solve it. Let's combine like terms. 10 minus 8 is 2 equals 4x. So how do you want to do this now? I leave this up to you. What's your next step? Tony, Ann, you want to say something?
I want to say to make the entire equation equal to 0. No?
It's not a quadratic equation. You're thinking about a quadratic equation, set it equal to 0. I mean, you can do that, but you don't really have to. You want to get all your x's to one side and your numbers to the other side.
Oh, you can move the 2.
I could move the 2, so okay, Tony Ann goes this way. 5x equals 4x minus 2. And since she did go this way, what is my next move?
Subtract 4x.
Subtract the 4x. These are linear equations. Don't forget how to solve linear equations. Get all your x's together, and 5 minus 4 is x equals negative 2. Yes, you guys already had it. That is your answer. However, I wish I wouldn't have crossed this out. This is a 1. Let me write it down again. And this was an x plus 2. And this was an x plus 2. So what we really need to do first, I didn't do it here on purpose. We have to find the RV. You look at your denominators, and since it's the same, the RV, set it equal to 0, and you get an RV that is x equals negative 2. And this solution, this RV, I mean, is the same as our solution. And when that is the case, That means -2 cannot be an answer, cannot be a solution. So this is called an extraneous solution. I can spell it. Extraneous solution. If you do get an answer but does not check. X equals -2 does not check because you get an undefined. There will be a 0 in the denominator, so in this case there is no solution. So it's always a good idea to find the RV first. Or if you watch this video again, find the RV first and then solve the equation. Compare the answer with the RV. If they are both the same, then there is no solution. -2 would make this equation undefined. Mark's typing something, so let's wait first. So be careful. There are some equations here that are no solution. Check the potential solution in the original equation. Any value from step 1 for which the equation is undefined cannot be a solution. Oh, you're not typing anything. It just shows me that you were typing anything. Okay, now you were typing. Oh, anyway. Want to stop right here? On Friday, I'm going to continue to do a couple more equations, but don't log in until 11:15. I will send you an email with the exact information, but that's it for today. Any questions? Okay, goodbye, everybody. Goodbye. Email me, attend virtual office hours, you know, all the help you can get. Okay, I'm going to disconnect. Okay, Christian, I want to talk to you for a second. Oh, my head's hurting.